Our project is the Plant Hydration Station by Karn Patel and Neil Babu. It is difficult to know when plants need watering. According to Missouri Botanical Garden, overwatering is one of the most common problems for plants, which can lead to plant death.
According to the survey conducted by Better Homes and Gardens of 2,000 millennials, they found that the average millennial kills 7 plants per year. And 46% of the respondents said that knowing how much to water plants was one of the most difficult parts about taking care of a houseplant. Millennials are also the most likely to get houseplants currently and in the future.
Prior existing patents include US 3758987A that relies on air and a capillary reaction to water the plant. Existing products include the automatic timer-based plant watering system and self-watering bulbs. However, the main issue with timer-based self-watering systems and watering bulbs is that the plant can be overwatered as they have no way of knowing when the plant needs to be watered.
For the solution, we both came up with 3 possible solutions. Then we made a design matrix with multiple design specifications. Each specification was assigned a weight based on its importance. Each design was given an initial score on a scale of 1 to 3 and was later multiplied by each specification's weight to give the final score. Scores are calculated by rating the solutions on a scale of 1 to 3. 3 meets specification, 2 somewhat meets specification, and 1 does not meet specification. The plant hydration station received a high score of 35 and was chosen as the final design. For the prototype, the sketch was used to help 3D model a pot that was able to contain the plant pot and electronics while also acting as a water reservoir. The testing procedure to test whether or not the prototype met the final design specifications included a 1-week unmonitored test followed by a 2-week monitored test. During the 1-week unmonitored test, the prototype was to run continuously for the full duration without any assistance, with the exception of filling up the water reservoir when it got low. The soil moisture level and the condition of the plant were recorded before and after the test, with the criteria being a pass if it successfully kept the plant alive and failed if the product broke down. The 2-week monitor test was to ensure that the code was running properly and the soil moisture level was staying within the specified range.
The result of the testing was that the prototype successfully passed both tests as the soil moisture level was within the specified range, and the sensors were able to tell the pump to turn on when the soil moisture level dropped. Additionally, another sign of success was that the plant experienced new leaf growth.
Throughout the entirety of this project, we have used various STEM skills. 3D modeling and printing was used to create the prototype that would house electronics. Coding was used to program the Arduino and the electronics so that they'll know when to water the plant. And finally, we had to have a knowledge of electronics so we know how to connect Arduino to the various inputs and outputs we had, which included pumps and sensors.